Hello! Today we are going to lecture on density, and then at the end of the lecture there will be a section for percent error. So what I would recommend doing is pausing the video and copying what's on the screen, and then unpausing it so you can hear me talk about it. If you can copy and listen at the same time, then don't feel like you have to pause it. So, density is an intrinsic property. An intrinsic property means that no matter how much of the substance that you have, it's all going to have the same density. So I decided to give you an example because sometimes definitions are just a little confusing. So for example, all iron objects have the same density regardless of size and shape. So if you've got a 5-gram sample of iron and if you've got a 20-gram sample of iron, those are both going to have the same they're both going to have the same density because density is a ratio of mass to volume. So you can alter the density of a substance by changing the temperature or pressure. Usually if you decrease the temperature, it increases the density, but water is an exception to that, and that's why ice floats. So solid water, ice, is less dense than liquid water. So below we have the density formula, D equals m over v. This is something that you have to have memorized for the rest of your life. I will never give this formula to you on any sort of worksheet or test or quiz. You've just got to know it. D equals m over v. At the beginning of school, we spent a lot of time with algebra and being able to isolate variables. So I'm only going to do that one more time, and that's here in this video. So D equals m over v. It is solved for density at this moment. If you wanted to solve for mass, we're going to multiply by volume on both sides. So that gives you mass equals volume times density. Okay. If you wanted to solve it for volume, we need to cross multiply because volume's in the denominator, so times by volume. So VD equals M. Solving for volume is a two-step problem, whereas solving for mass was just a one-step problem. So again, you have to know that D equals M over V. Okay? If you know like that your personal weakness might be algebra or you just are not confident in your algebra skills, go ahead and memorize these two formulas too. That density is mass over volume. Mass is calculated volume times density. Volume is calculated mass over density. Okay? Now, I know that you've done a lot of density problems before, probably in earth science, maybe in biology. So the word problems really aren't that big of a deal, but I do want to talk about some things that you might need to keep your eyes out for when solving a density problem. So first off, if you were in a lab, you're going to find the mass just by using a balance. So if you wanted to find the mass of a rock, you're going to put the rock on the balance. Okay? If you're trying to find the mass of a liquid, you're not just going to pour the liquid onto the balance and hope that all of the liquid stays on the balance, right? You're going to use a container. So if finding the mass of a liquid, you will have to subtract the mass of the container. Okay? But our balances have a 0 button. So that means that you can put the container on the balance and then hit a button, and the balance basically ignores what's on the balance. It'll only measure the liquid then. So, but in a word problem, you're probably going to have to subtract out the mass of your container. Okay, so just read the word problem carefully. Next, finding volume. If you have a liquid, you're just going to use a graduated cylinder. Okay, you're going to take, I would use the graduated cylinder, put it on a balance, zero it out, and then pour in a known amount. So you would measure how much liquid you have, but then I would also just read the mass. So you would be able to get mass and volume in one step. So liquid's pretty easy to find the volume of. Now, Finding the volume of a solid is going to be a little bit different depending on what type of solid you have. If you have a regular shaped object, like a cube, you can use volume equals length times width times height. Okay, you can use the formula for a cylinder or any of those, but the one that I think you'll most commonly come across is volume equals length with height. If you have an irregular shaped object like a rock and you wanted to find the volume of the rock, you're going to use the water displacement method. Okay, the water displacement method is when you'd have a graduated cylinder and you're going to read your meniscus, you're going to read your initial, and then you're going to take the rock that you have and you put the rock in. Okay, and then you're going to subtract. So VF minus VI is going to give you the volume of your rock. Okay, so those are all things that you'll come across in word problems. So some of the word problems are just going to have you solve for density, mass over volume, and you'll have to manipulate the data like I've talked about here with MV. But you might also need to solve for mass. You might also need to solve for volume. Okay, so basically read every problem that you come across carefully, organize what you're given, and then make a plan of attack. So I'm going to work two problems, but they both are just asking you for density. Know that your worksheet problems are going to ask you for more than just density. Okay, so here's problem number one. A flask that weighs 345.8 grams is filled with 225 milliliters of carbon tetrachloride. The weight of the flask in carbon tetrachloride is found to be 703.55 grams. From this information, calculate the density of carbon tetrachloride. So this says calculate the density. So we're using D equals M over V. So I know that this is a volume because I have units of milliliters. So there's my denominator. Okay, now my masses, I have a gram here and a gram here. We don't just pick one, we're going to have to use both in some capacity. So when you read that again, I have a flask that weighs 345 grams, and then I fill it with carbon tetrachloride, and the mass of the flask and the carbon tetrachloride is 703.55. So we're just interested in finding the mass of the carbon tetrachloride. So this is where we're going to subtract 703.55 grams minus 345.8 grams. And so here's our problem. Okay, so first off, 703.55 minus 345.8 gives us 357.75 grams. We care about sig figs because we're chemistry students. So because this is a subtraction problem, I'm only going to have one decimal place. So 357.8 grams divided by 225 milliliters gives us 1.590222. Our units are going to be grams per milliliter. Again, we care about sig figs, so my answer can only have 3 sig figs because of my bottom value. So 1.59 grams over milliliters is that first problem. Okay, so again, I read the problem, read that it wanted me to solve for density. I took the data that was given and I plugged and chugged. Okay, you guys try the second one, pause the video, and then when you have it finished, unpause it and see if you got it right. So again, maybe pause the video and copy what's on the screen, and then listen to me talk, okay? So percent error is a way for us to measure or quantify how accurate you are with measurements. So quantifying something, if you ever hear that, that means you're going to have a value of some sort. You're going to have a quantity, a value. So if you have a 1% error, that's pretty good. We want a low percent error. Want low percent error. That means that we really didn't mess up. So if you did a calculation and ended up with 45% error, then you know that you're way off. Okay? So here again is the formula. The formula for percent error. Percent error equals actual minus experimental all over actual times 100. So note that these are absolute value brackets. So if you were to subtract the numerator and get a negative value, then you know that you need to make it positive because it's an absolute value. So the actual value is always going to be given to you in the problem. And some words that you might see that kind of give away that it's your actual, it could say the true value. It could say the known value. Some could say the accepted value. Okay. So not all the problems are just going to explicitly say the actual value. Some, you might, like I said, you might see true value, known value, accepted value. Okay. The experimental is what's done in a lab. Most of the problems are going to tell you that it was done in a lab by a student. Okay. You have to have this formula memorized. I usually just write percent error equals accepted minus experimental all over accepted times 100. Okay, so with that memorized or written down, we're going to work a couple of problems. All right, so here's problem number 1. The density for ammonia was measured to be 0.7134 grams per milliliter. The actual density is 0.6028. What is the percent error? So our formula, actual minus experimental all over actual times 100. So actual density, so there's our A, 0.6028 grams per milliliter. Our experimental, 0.7134 grams per milliliter. That's all in absolute value brackets, all over 0.6028 grams per milliliter. So I want you to see, I've got grams per milliliter on the top and grams per milliliter on the bottom. So those are going to cancel. So 0.6028 minus 0.7134 gives us a negative value, but I get to ignore the negative sign. So 0.1106 divided by 0.6028 times 100. Gives us 18% error. So that's not great. We know that you should probably go back and redo your procedure if you've got 18% error. Okay, so let's look at the second one. A student estimated a mass of an object 3 times to be 247 grams, 245 grams, 242 grams. Upon carefully measuring it, found the actual mass to be 240 grams. What is the percent error? So again, actual minus experimental all over actual times 100. So our actual value is absolutely 240 grams. So I know the first part of my numerator. But do I just pick one of these random values, like pick the median of it? When you're given multiple pieces of data, you got to take an average of it. So 247, 245, 242, add them up. It's going to give us 734, we divide 734 by 3, and that gives us 245 grams as our average data point. Okay, so when it comes to sig figs, you're not going to round to 1 sig fig. You can see this as an exact number. Okay, remember when we went over notes for sig figs, exact numbers have an infinite number of significant figures. So do not round to 1 sig fig here. So this is my experimental value. I had taken an average of what I was given, so 245 grams. So now we plug and chug. 240 minus 245. Again, it gives me a negative value. So I'm going to have 5 divided by 240. All right, so that brings us to 5 divided by 240 times 100. So that's going to be 2% error. So that's not that bad. Obviously, if you're measuring something and you're getting a different mass every single time, you should know that there's something wrong with the balance. Okay, so ways that you can practice density and percent error is going to be page 36. Some density specific questions are going to be 1 through 4, and then 9 and 10 are going to be density problems. Okay, percent error problems are going to be 5 through 8. So you also can, any old time you want to look, you can find worksheets for anything you want to do on the internet. Just Google density practice worksheet or Google percent error worksheet. So that would be the end of material for Unit 1.